Hello. So today I'm going to do a demonstration or an example from WebWorks set 13, which is about second order modeling. And then problem 3, we have this question: determine r, omega naught, and delta so as to write the function u of t is minus 3 cos 5t plus 2 sine 5t in the form of u of t is r cos omega naught t minus delta. By the way, r is called the amplitude and delta is the phase of this oscillation. So let me start by giving a little bit of the background of this. You might remember that we have a spring and a mass on a spring. And if we make, in this case, it's u of t is the distance below the equilibrium. And Newton's law says that mass times acceleration is the force. Mass times d squared u dt squared is minus k times u, or mu double prime is minus ku, or u double prime is minus k over mu. And k and m are positive constants, so this is a negative constant times u, so we let omega naught be square root of k over m, so omega naught's positive, and we get u double prime equals minus omega naught squared u. And that's kind of nice because it really focuses the fact that this omega naught squared is a positive constant, because any real number squared is positive. So u double prime is a negative constant times u. And you might remember that we want to memorize the solution to that differential equation. It's really the most important one after, say, u prime is a times u, which gives me exponential. This gives me sines and cosines. So the general solution is u of t is c1 cos omega naught t plus c2 sine of omega naught t. Okay, now how do we make sense of that? One of the best ways of making sense of that is that the sum of a cosine and a sine, both with the same period, 2 pi over omega naught, can be written as just a cosine with some other amplitude and some phase shift. So we can write this as r cos of omega naught t minus delta. And to figure out how they relate, we can use a trig identity on cos of a minus b. Let's remember what cos of a minus b is. That's cos of a cos of b plus sine of a sine of b. Right? So in this case, a is going to be our omega naught t, and b is going to be delta. All right, so this thing is equal to r times a big bracket times cos of omega naught t times cos of delta plus sine of omega naught t sine of delta. All right, so if I distribute this through and collect the terms in front of cos omega naught t, I get r cos delta times cos omega naught t plus r sine of delta sine of omega naught t. Okay, so these are the same if I let r cos delta be c1 and r sine delta is c2. Okay, so in fact that gets me to I'll leave that there, but let's just summarize. That gets me to the equations that you need, and you can actually jump right into this when you do the problem. The relationship between the constants in the r and the delta are that C1 is r cos delta, and C2 is r sine delta. Okay, and that hopefully looks a little bit familiar. This is sort of like polar coordinates. I'm going to do it over here. You might remember that x is r cos theta in y equals r sine theta is polar coordinates in the xy plane. Here's x in y, and you might have a point, say, over here. Here's a point x, y. You have r and theta are the polar coordinates. And the same thing happens over here. I can think of the C1, C2 plane. And for a particular point in the C1, C2 plane, in fact, let's just choose -3 and 2. In the C1, C2 plane, we want to find r and delta. If we know what that r and that delta is, we have it made for C1 and C2. For the C1 is -3, C2 is 2. All right, so let's actually take care of a real easy part here. What does omega naught have to be? Right, if I wanted the omega naught here, the factor in front of the t, has to be the same as the factor in front of t here. So the first thing we have in this problem is that omega naught has got to be 5. Right? And then we need to find r and delta. So we got that picture up there. So r is actually always easy to find there. To turn this around, r is always square root of c1 squared plus t2 squared. Or it might be r is the negative of that, but we don't usually allow that. Sometimes we do. You might remember you got some pretty pictures in polar coordinates when you allowed r to be negative and got little roses and stuff like that. But they want us to choose r positive, and so I just take the positive square root here. Okay? Now, the other thing that's a little bit weird about this is that I can't really get an equation for delta. The best I can do is say that tangent of delta is going to be c2 over c1. And I get that by taking that equation over that one. R sine delta over r cosine delta is tangent delta. That's c2 over c1, right? But you need to draw a picture, though. To get delta. All right. So I'll describe a little bit how that works. So let's do this example here. We got the point -3, 2. I'll redraw it up there. -3, 2 in the C1, C2 plane. Okay, the easy thing to do is r. R is square root of -3 squared plus 2 squared. So this is square root of 9 plus 4. R is square root of 13. Okay. Now what about delta? Again, delta is this angle here. Okay. But arctangent, I'm gonna find delta by using an arctangent. But arctangent of 2/3 would be this angle here. This is the angle arctangent of, negative C2, 2 over negative 3. That's arctangent of negative 2/3, right? This thing here is always between minus pi over 2 and pi over 2. The arctangent of anything is between the negative pi over 2 and plus pi over 2, right? So that's why it gives us this angle in the fourth quadrant, written as a negative angle, okay? So delta is that plus pi, because this angle here is pi. So actually, delta is arctangent of negative 2/3 plus pi. Or I can leave it like that, or I can also realize that arctangent is an odd function, so this is actually equal to negative arctangent of 2/3 plus pi. And I can put either one of those, say, in the web work. So I can actually do that web work, writing out ARCTAN, or do this on the calculator, make sure I'm in radian mode, and then plug that decimal in with 4 decimal places. All right. So let's do another few examples of this. Okay. And so the answer to this question is omega naught's got to be 5, because there's a 5 there. R is square root of 13. Delta is this number, which you need a calculator to estimate it, but web work is a calculator. So let's do another, maybe just another few. One of them is, suppose you've got, say, u of t is negative, I don't know, negative 5 sine of 3t. Well, first you need to have omega naught is 3, because that's the omega naught. Okay? And then I'm actually not even going to use these formulas. I'm just going to plot in the C1, C2 plane what these constants are. I don't see it. I don't see any cosine terms, so that means that C1 is 0 and C2 is negative 5. So that means I got this point here at 0, negative 5. C1 is 0, C2 is negative 5. So what's R? Well, R is 5, right? R is the distance from the origin to that point. And then delta here is minus pi over 2. Okay? Now you notice if I try to use this formula, I'd be fine here to find R. Square root of negative 5 squared is square root of plus 25, and that's 5. Okay, so I get R is plus 5, good. But I try to plug in to this formula, C2 over C1 is negative 5 over 0, can't divide by 0, that's undefined. Right? So you kind of need the picture for that one. And some of you will have that one. Well, if there's enough people, it's one of the possible random choices. Let's do another one. Let's do another example. Let's suppose I'm over here. Negative 2, negative 2. Okay, so C1 is negative 2, C2 is negative 2, I'm down here. Okay. Again, I just need to find R, and here's R, here's delta. Okay? So, just kind of from geometry, R is 2 square root of 2. That distance is 2, that distance is 2, so that's 2 square root of 2, the diagonal of a square. And then delta is, well, I can think of delta as, right, pi plus pi over 4. Delta is like 5 pi over 4 this is true, but they want you to find a delta that's between minus pi and pi. So the thing you'd have to enter into WebWork for this would be delta is minus 3 pi over 4. This gives you the green flash, or the green bar, that WebWork says it's okay. Okay, all right. And that is this is another representation. This is actually the delta we're going to use on this one. Because, right, there's lots of different deltas that give me the same point in the polar coordinates, right? Another thing I could do is, like, I could add 2 pi to any of these and it would still be right in a way, but it wouldn't be there in that correct interval for delta. So you get a unique answer in that interval. Okay? Just one more example of that is C1 is, say, -3, C2 is 0. That is R is 0, and delta is going to be now pi. Here's the picture. It's way over here. Right? And actually, delta of negative pi would also actually be true, but it's not correct, because that's why delta's got to be bigger, strictly bigger than negative pi, but it can be equal to pi. So that's the one you would use if those are your numbers. All right. Well, have fun with this set. It's due next Monday night at midnight, right? Okay, hang in there. I hope you're all doing well. You can always contact with me with any questions you have. Okay, bye.